Practice set 21 is solving equations with a fractional equation. The variable in problem number 1 is being multiplied by the fraction 4/5. To counter a multiplication, typically we would divide, but that's going to end up giving us a fraction in the numerator and the denominator. Not a pretty sight. The alternative method is to multiply by the reciprocal of the fraction, which, if you recall, the reciprocal is found by inverting or turning the fraction upside down. So to counter a multiplication by 4/5, I'm going to multiply by the reciprocal, which is 5/4. Maintaining equality means I'm going to multiply the right-hand side by 5/4 as well. Multiplying fractions together, if there's something common in the numerator and the denominator, we can cancel them out. The 5's in the numerator would result in a 1. The 4 in the numerator and denominator would result in a 1, leaving a 1 times x. On the right-hand side, I have a fraction times this whole number. Any whole number is understood to have a denominator of 1. I could multiply 36 and 5, dividing the result by 4, or reducing, recognizing that 4 goes into 36 9 times. 4 divided by 4 is 1, leaving a 9 times 5, or 45. X equals 45 for a solution. Checking that solution, 4 times x, which was found to be 45, divided by 5, does it equal 36? Well, reducing this before doing the multiplication, 5 divided by 5 is 1, 45 divided by 5 is 9, 4 times 9 is 36. True expression, meaning our solution is correct. Problem number 5 has the variable being multiplied by a fraction. Same procedure, with one additional consideration. We have a negative number. We always want to solve for a positive variable. So multiplying here by the reciprocal would be 5/4, but to end up with a result of a negative, we're going to multiply by a negative 5/4. What's done to one side gets done to the other side to maintain equality. A negative times a negative is a positive. A 5 divided by 5 results in a 1. A 4 divided by a 4 results in a 1. The 1's multiply to give us a 1x. On the right-hand side, this negative 4 is understood to have a denominator of 1. When I multiply my fractions, I have a value of 4 in the numerator, canceling out the 4 in the denominator. I have a negative times a negative, same signs multiplied give us positive, and a 5 times 1 is going to give us a positive 5. The solution being x is equal to 5. Checking the work here, replacing the variable with 5, determining whether in fact we do end up with a negative 4. The 5's are going to cancel out, leaving a 1. We have a 4 times 1 is 4, and nothing altered this negative that was in the original problem, which gives us the true statement, meaning x equals 5 is our solution.